Hello Physics Nation, my name is Nate Larmond, and I'd like to do a simple problem from openstax 11.4. It reads, the greatest ocean depths on the Earth are found in the Marianas Trench near the Philippines. Calculate the pressure due to the ocean at the bottom of this trench, given its depth is 11 kilometers, and assuming the density of seawater is constant all the way down. Whoops, okay, so here's the given information. The density of seawater is slightly higher because of the salt dissolved in it than normal water. And we have to do a simple unit conversion to change 11 kilometers into 11,000 meters. Once you have these two pieces of given information, you just substitute into pressure equals rho GH. So there's the density. Once you multiply by G, you have the weight density. And 11,000 meters is the height of the water column above you. Notice, Mount Everest is not as tall as the Marianas Trench is deep. So you get 109 million pascals. Let's compare that to atmospheric pressure. If you divide by 101 kilopascals, you get over 1,000 atmospheres of pressure at the bottom of the Marianas Trench. Thanks for watching, and see you in the next video.